Hello, this is our third video from 1.2, the graph of a function. This is going to be a problem from 23 to 28. They're all pretty similar to this one, but they're like 7 parts, and so that's probably it's more tedious than anything else. But if you understood my overview section, this should be fairly easy. On this one, on part A, we have a function f of x equals negative 3x squared plus 5x, and they want to know is negative 1, 2 on the graph of f of x. So, yeah, well, does that mean I'm going to have to graph it and see if that point is kind of in that location? Well, you could, but it wouldn't be very accurate. The easiest way to do it is evaluate the function at negative 1. And what are you hoping the output to be? You're hoping the output to be 2, because if its input is negative 1 and the output is 2, negative 1, 2, negative 1, comma 2 is indeed an ordered pair on that graph. So all I need to do is test f of negative 1 and see what that is. So that's what I'm going to do, f of negative 1. So I get negative 3 times negative 1 squared plus 5 times negative 1. Negative 3 times negative 1 squared is a negative 3. Negative 1 squared is 1. And then 5 times negative 1 is negative 5. And that gives me negative 8. So negative 3 minus 5 is negative 8. And that is not 2. So therefore, the answer is nope. It is not a point on the graph. It would have to be 2 in order for it to be a point on the graph. So you would just say, answer simply, no, it's not. Now the next one is, if x is negative 2, what is f of x? So what they're basically saying is, well, what is f of negative 2? They could just ask it that way. What is the value of f of negative 2? But they say, well, if x is negative 2, so then you drop that into the x. So that's just another way of writing f of negative 2. So we evaluate that. And it's going to be negative 3 times negative 2 squared plus 5 times negative 2. Now, negative 2 squared is 4. 4 times negative 3 is negative 12. 5 times negative 2 is negative 10. And that's a negative 22 if I didn't make a mistake on my math. Let me make sure. Negative 2 squared is 4. 4 times negative 3 is negative 12. And then negative 12 and 5 times negative 2 is negative 10. So that is negative 22. And the next question is, what point does that correspond to on the graph? And that point would be x is negative 2 and y is negative 22. So it's negative 2 comma negative 22. Now, the next question is, well, what if f of x is negative 2? Now, that's different. They're not asking you if x is negative 2, what's f of x? Now they're saying f of x. Now, remember what f of x is. F of x is the output, which is the y-coordinate. So that's what your answer needs to be. What x value gives me that? Well, you just take the f of x up there and set that equal to negative 2. And you solve that quadratic equation. Now, I would like to move everything to the left to make the 3x squared positive. So that's going to be 3x squared minus 5x minus 2 equals 0. And I believe it factors. It's 3x times x, and a 2 on this end, and 1 on this end, and a minus and a plus. So that would be negative 6x plus 5x, negative 1x. So x is negative 1/3 in this particular case, and x equals 2 in that case. So that's what the x value is already. Notice it says what point or points, so there could be more than one. Is or are, okay? So there could be one, or there could be more than one. Now you're like, well, wait a minute, that's not a function then. And remember now, a function is for each x, there's only one y. It could be the same y. So negative 1/3 gives me negative 2, and that's all. And 2 gives me the negative 2 also. So that's fine. It's different inputs given the same output. That's fine. But one input given 2 outputs is a problem. So this is what points are on the graph. So it's negative 1/3 comma negative 2 and 2 comma negative 2. Those are the points. Now the next part is, what's the domain? Well, this one's easy because this is quadratic. There's no fractions to make the denominator 0. There are no square roots. that way that you can't put negative numbers in. This is the parabola. So this thing right here are all real numbers. And what are the x-intercepts? Now remember, to find the x-intercepts, you set the y-coordinate equal to 0. So it's kind of like C, except you don't set it equal to -2, you set it equal to 0. So 0 equals -3x squared plus 5x. Now, you're like, well, how do you solve that? There's a couple of ways. Since it's set equal to 0, you can use the zero factor property. You can use the quadratic formula if you really want to. I'm going to get it in factored form right now. And you're like, well, you can't FOIL it out because there's no number out here. Well, that makes it even easier. Because if there's two terms, and there's no constant term out here to try to factor like I did over here on part C, you had to break up in two binomials. Here, it's basically a monomial times a binomial. Because all you do is take out the x. So it'd be -3x plus 5. So now it's factored. So you said each factor equals 0. So x equals 0 and -3x plus 5 equal to 0. So it would be x equals 5/3 at the end. So the intercepts are going to be 0, 0 and 5/3, 0. So if you were wanting to graph this, you know a lot of things already. You know the domain is all real numbers, and it didn't ask you to graph it, but this is kind of what's going on. You've got a point at 0, 0. You've got 5/3, comma 0, which is 1 2/3. So you know it's going to cross there. You also know it has -1/3, comma 2. And you also know it crosses at, what is it? That's -1/3, -2, sorry. So -1/3, -2. So it's over here and over here. So -1/3, 2, -2 is right there. And then at 2, -2, which is right there. So you know that. So you know these 4 points up, but that's not enough to give me a graph. Well, I know you got to get more information to graph it. You need something called vertex and stuff like that. But let me kind of show you what it looks like. It looks kind of like this. That's kind of what it looks like. You're like, well, I wouldn't know that. You will later, so don't worry about that right now. So, but anyway, those are the x-intercepts. Now the y-intercepts is just setting the x equals 0. But you're looking at the picture now. It's obviously what the y-intercept is. Here's the y-axis. Crosses at the origin. So if you have an x-intercept at the origin, then definitely there's a y-intercept at the origin because that's where the two axes meet. So that's 0, 0. Now, G, you're like, okay, what are the zeros? Oh, great, another question. But this is easy because you remember what I said at the very first one? I said the zeros are the x-intercepts as long as they're real. And when you solve this in part E and you set that equals 0, 0 and 5/3 are real numbers. So the zeros are x equals 0 and x equals 5/3. So those are the zeros. Now notice zeros are just numbers. X-intercepts are ordered pairs. So if you want to make somehow find a difference between the two terminology, the x-intercepts are points, but the x-coordinates of those points are the zeros. But remember, all zeros are not necessarily real. They could be complex. So that's where you have to be careful. So anyway, so this is a problem from 23 to 28, namely number 24. I have one more video, and we're going to do one more problem in the last video, and it's going to be problem number 32. So thank you for watching.